Good morning, everyone. Welcome to the channel GK Key for Exam. And today, the day has arrived that India is going to launch its Chandrayaan 3 mission. The Indian Space Research Organization on 14th July 2023 at 1435 hours is all set to launch its Chandrayaan 3 mission from the Satish Dhawan Space Center in Sriharikota, Andhra Pradesh. The Chandrayaan 3 spacecraft will be launched by the launch vehicle Mark 3. So let's move and know the about the mission Chandrayaan 3. Chandrayaan 3 Chandrayaan-3 is India's upcoming lunar mission, which aims to be the world's first mission to soft land near the lunar South Pole. If the launch takes place as scheduled, the landing on the lunar surface would most likely to take place on August 23rd or August 24th. The mission will have three major modules. The first module is the propulsion module, which will carry the lander and rover configuration till 100-kilometer lunar orbit. The second, Lana module, which has the capability to soft land and deploy the rover. And the rover, it is a vehicle that moves around the planet or astronomical objects and study the moon. So in that, there will be a question that what is the lunar south pole? So the lunar south pole is the southernmost point on the moon. It is of special interest to scientists because of the occurrence of water ice in permanently shadowed areas around it. The lunar south pole region features craters that are unique in that the near constant sunlight does not reach their interior. Such craters are cold traps that contain a fossil record of hydrogen, water ice, and other volatiles dating from the early solar system. In contrast, the lunar North Pole region exhibits a much lower quantity of similarly sheltered craters. So, Chandrayaan 3 mission is going to launch in the lunar South Pole. So in the next slide, we're going to study more about it. What will be the challenges of landing on the south? So in this figure, we can see that this is the south pole, lunar south pole of the moon. And here we can get water, water ice, hydrogen and all. And sunlight never reaches this point. So what will be the challenges faced by the ISRO to landing on the South Pole? Previous spacecraft have mostly landed near the equatorial regions of the Moon, a few degrees latitude north or south of the lunar equator. Landing near the equator is easier and safer due to the hospitable terrain, smooth surface, absence of steep slopes, and ample sunlight for solar power instruments. But in the lunar South Pole, on the other hand, presents a challenging terrain with extreme temperatures and areas that are permanently shadowed, receiving no sunlight. So in this figure, we can see that the terrains are not good or smooth. It is high and low. So it will be difficult for the mission to get land here. Let's know about more in the next slide. In this slide, we can see why ISRO wants to explore the moon's south pole. And the first reason is water resources. The South Pole region is believed to have water molecules in substantial amounts, possibly trapped as ice in the permanently shadowed craters. Second, exploring and confirming the presence of water is essential for future human missions and the potential utilization of lunar resources. Third, scientific discoveries. The extreme environment and the presence of permanently shadowed regions provided a preserved record on the Moon's history and the early solar system. Fourth, clues to Earth's history. The Moon is thought to have formed from debris generated by a giant impact between a Mars-sized object and the early Earth. Fifth, by studying the lunar Earth pole, scientists can gain insights into the material and conditions that existed during the formation of Earth-Moon system. Sixth, global collaborations. ISRO-NASA successfully confirmed the presence of water from the data taken by the Chandrayaan-1 mission. The Indo-Japan collaboration, LUPEX, aims to send a lander and rover to the Moon's south pole around 2024, which is this July 24th, July 14th, means today. And the last, technological advancements. By undertaking missions to this region, ISRO can develop and demonstrate innovative technologies for soft landing, navigation, resource utilization, and long duration operations that can be applied in future space missions. So these are the reasons why Indian Space Research Organization wants to explore the Moon's south pole. So let's move to the next slide. The next slide is the comparison between the Chandrayaan-1, 2 and 3. So here we can see that Chandrayaan-1, it was launched in 2008. The objective was to study lunar surface. The components was orbiter, moon impact probe. The findings which we get from Chandrayaan-1 were it confirmed the presence of lunar water, lunar caves, tectonic activities, faults, and fractures. Communications, but when the mission was launched, the communication issues after 312 days of operation. The launching vehicle of Chandrayaan-1 was PSLV, Polar Satellite Launched Vehicle. In case of Chandrayaan-2, which was launched in 2019, the objective was to study the lunar surface and land rover on the lunar south pole. The components were orbiter, lander, which was named as Vikram, and rover, which was named as Pragyan. And the findings which we get was the building on the evidence of water molecules shown by Chandrayaan-1. But in communication, lander crash landed and the rover unable to operate. So it was not a successful mission. The launched vehicle for Chandrayaan-2 was GSLV Mk3, Geostationary Launched Vehicle. And the landing site was also lunar South Pole. The Chandrayaan-3 mission, third, which is scheduled for today, 14 July 2023, it demonstrates landing capabilities for lunar polar exploration mission. In this, the components are propulsion module, lander, and rover. In this mission, orbiter is not placed. This mission is going without orbiter. Findings which will be get after August 23rd or 24th by 24th August. And the launched vehicle is LVM-3. The landing site is lunar South Pole, and the major partner for Chandrayaan-3 is Japan for lunar polar exploration mission. So let's see in the next slide about the different launch vehicles launched by ISRO. Here we can see about the launch vehicle Mark III, which is going to take in the Chandrayaan-3 mission. It is a three-stage launch vehicle consisting of two solid propellants S-200 strap-ons on its sides and a core stage comprising L-110 liquid stage and C-25 cryogenic stage. The newest rocket is capable of launching 4,000 kilogram class of satellites into a GTO geosynchronized transfer orbit and 8,000 kg of payloads in the low Earth orbits. So it is the best launch vehicle till date for India. Let's move to the next slide and see the comparison between the launch vehicles developed by ISRO. What are the other launch vehicles developed by ISRO? The first one is Satellite Launch Vehicle (SLV). The first rocket developed by ISRO was simply called SLV or Satellite Launch Vehicle. It was followed by Augmented Satellite Launch Vehicle or ASLV. The second, Augmented Satellite Launch Vehicle (SLV) and ASLV both could carry small satellites weighing up to 150 kg to lower Earth orbits only. The Augmented Satellite Launch Vehicles operated till early 1990s before PSLV, the Polar Satellite Launch Vehicle, came on the scene. The next is Polar Satellite Launch Vehicle. The PSLV, Polar Satellite Launch Vehicle, first launched was in 1994 and it has been ISRO's main rocket ever since. Today's PSLV, however, is vastly improved and several times more powerful than the ones used in the 1990s. It is the first India's launch vehicle to be equipped with liquid stages. The PSLV is the most reliable rocket used by ISRO to date, with 52 of its 54 flights being successful. It successfully launched two spacecraft, Chandrayaan-1 in 2008 and Mars Orbit spacecraft in 2013, that later traveled to Moon and Mars respectively. The next launched vehicle is Geosynchronous Satellite Launch Vehicle (GSLV). GSLV is much more powerful rocket meant to carry heavier satellites much deeper into space. To date, GSLV rockets have carried out 18 missions, of which 4 ended in failure. It can take 10,000 kgs of satellites to lower the Earth orbits. The indigenously developed cryogenic upper stage forms the third stage of GSLV Mk2. Mk3 versions have made ISRO entirely self-sufficient in launching its satellites. Before this, it used to depend on European Ariane launched vehicle to take its heavier satellites into space. The GSLV Mk Mark III was used to launch the Chandrayaan-2 mission to the Moon in 2019, which was the first operational flight of the rocket. Then in 2022, ISRO has renamed the GSLV Mk3 as Launched Vehicle Mark III. A GSLV for the geostationary orbit will continue to be called so. The LMV3 will go everywhere in geosynchronized Earth orbit, medium Earth orbit, low Earth orbit, and missions to Moon and Sun. So these was the difference between the launched vehicles. And here is the diagram. We can see that SLV, which height is 22.7 meter, lift-off weight is 17 T, propulsions all solid, payload mass is 40 kg, orbit it can go up to low Earth orbit. In the augmented satellite launch vehicle, the payload mass has increased and orbit it can go up to low Earth orbit. The PSLV XL3, the payload mass has increased and the propulsion has been solid and liquid. And the orbit is 475 sun-synchronized polar orbit. The GSLV Mk3 It is the solid, liquid, and cryogenic propulsion, and the payload mass is 2200 kgs, and it can orbit up to geosynchronized transfer orbit. Now, the last and the latest is the GSLV Mk3, which is known as LBM3, which is propulsions of solid, liquid, and cryogenic, and payload mass of 4000 kgs, and can travel up to geosynchronized transfer orbit. So these was the information all we can get for Chandrayaan 3 mission. Thank you for watching GK Key for Exam. Please like, share, and subscribe the channel for more GK updates. Thank you.